All right, systems of linear equations. This is the substitution method. So you're going to be given two equations like this, and we're trying to find the solution, the x and y value that make both of these true. So what you do is you take both equations and split them. And one of them will say x equals, it's this one. And you're going to take this value right here, and you're going to substitute it for the x. See, x is this, so that's an x. We can replace it with negative 2y. And now that we have an equation that's all y's, we can solve it. So there's our y value. It's negative 1. And once we have the y value, we can then plug it in over here. And that gives us an x value of 2. And that's our solution. How do we know it's correct? Well, we still have to check it. So if you take and plug it in, it should give us 4. So that's 6 plus negative 2, and that is indeed 4. It checks, but it also has to work for this one. So let's try the next one. Negative 1 equals negative 2 times 2. Let's plug that in correctly. Negative 1, one more time, 2 equals negative 2 times negative 1, which is 2. So that checks as well. And we know our solution is correct. So that's what we're looking for, an x and y value that make both of these equations true. All right, so let's try another one. All right, so we rewrite them. 4x minus 3y equals negative 2. And then x plus 2y equals 5. Now, if you notice each of these, neither of them say x equals or y equals. So what you have to do is solve. And you find the one right here that has no coefficient, basically a coefficient of 1. Right? So no number in front. Let's get rid of no coefficient because that's wrong. Just coefficient of front. I'll put no number in front of variable. All right, and that's a coefficient of 1. And that's what you want to solve for. So we get x equals, subtract 2y from both sides, like that. And the reason we pick this one is if you pick any other one, do not write this. Let's solve for x. We get 4x equals 3y minus 2. Divide by 4, divide by 4, divide by 4. Fractions. And we don't want fractions. They'll still work, but it's more work than you need. So you find the one with a coefficient of 1, no number in front, and solve for it. Now we can come over here and substitute that x for its value, which is minus 2y plus 5. And now we can just solve. So negative 8y plus 20 minus 3y equals negative 2. It's negative 11y plus 20 equals negative 2. Subtract. And then divide. So y equals 2. Come back over here and plug it in. And there we go. 1, 2. And again, we still want to check it. So 4 times 1 minus 3 times 2 equals negative 2. That's 4 minus 6 is negative 2. Checks. Check the next one. 1 plus 2 times 2 equals 5, and that's definitely 5. And there you go. Let's try one more. This one is special. So 4x minus y equals 7. Negative 12x plus 3y equals minus 21. So what letter do we solve for? Coefficient of 4, 1, 12, and 3 right here. So minus the 4x. Divide by negative 1. And now we can substitute. Okay, so 12x minus 12x is 0. So minus 21 equals minus 21. Now, is that true or false? That is true, which means we have an infinitely many solutions. So going back to the graphing, remember, if you get a false statement, it means they're parallel, there's no solution. If you get a true statement, it means they're the same exact line, there's infinitely many solutions, which is what we have here. These are actually the same line. So we already solved that one for y. Let me solve the other one just to show you. And so that gives us y equals 4x minus 7. Same exact equation. And that's why we get infinitely many. They're the same solution. That's it. That's substitution.